smart, and you want to do it efficiently.
That's what we do here.
Exactly. Welcome to the deep dive. We tackle a big topic, sift through the dense stuff.
Just source material.
Right, the sources. And we pull out the key ideas, the surprising bits you really need without you getting bogged down.
And today, we're diving into something pretty ambitious. It's Ray Kurzweil's The Singularity Is Near, a really debated book.
Definitely debated.
We're looking at his core arguments, his vision for this future where tech changes so fast it just fundamentally changes human life irreversibly.
Ambitious is, maybe an understatement.
Yeah.
I remember one review said something like, all the change in 1,000,000 years crammed into the next 5 minutes.
Wow. Yeah, that captures the scale he's talking about.
So our mission here is to kind of unpack the main ideas from Kurzweil, figure out what he thinks the impact will be, touch on some different viewpoints.
Without getting lost. Keep it focused.
Exactly. Make it compelling. Okay, so let's get into the foundation, the core idea.
Right. So at the heart of it all is what Kurzweil calls the law of accelerating returns.
Okay.
This is his big thesis. Basically, evolution, especially tech evolution, it doesn't move steadily. It's not linear.
It speeds up.
It speeds up exponentially, especially information technologies.
Ah, okay. He uses that analogy, doesn't he? The lily pads.
He does. Yeah, the lily pads on the lake, they double every couple of days, say.
And at first you barely see them, like less than 1% covered.
Right. So the owner thinks, oh, plenty of time, goes on vacation.
Comes back and boom, lake's totally covered.
That's exponential growth. Looks slow, then suddenly it's everywhere. It really sneaks up on you.
But I mean, does that always happen? Do some things hit a wall? Are there, like, limits Kurzweil maybe doesn't focus on enough?
That's a fair question. And yeah, historically, not every trend is purely exponential forever. You hit resource limits or things get way more complex than expected, society changes.
Yep.
But Kurzweil's counter is that usually when one technology, one paradigm starts to plateau.
Something else takes over.
Exactly. Something new, often even more powerful, emerges. Think vacuum tubes to transistors, then integrated circuits. Each had limits, but the overall acceleration continued.
Okay, that makes sense. So he gives examples of this acceleration happening now or recently, stuff that seemed like science fiction not long ago.
Oh, absolutely. Like computer chess. Gary Kasparov, world champ in '92, basically laughed off the idea a computer could beat him soon.
Oh, right, I remember that.
5 years later, IBM's Deep Blue beats him.
Just 5 years. Wow.
And it wasn't just a little better, it was a leap, powered by that exponential computing growth. And we see it elsewhere, right?
Yeah, like what?
Computers matching or beating humans in medical diagnosis, flying planes, even military tactics with autonomous weapons, complex financial stuff.
So it's everywhere. And a lot of that computer power comes down to Moore's Law.
Moore's Law is, a shift driver, the doubling of transistors on chips.
Okay.
Though Kurzweil points out the doubling time for overall IT capability, price performance, speed, storage, bandwidth, it's often been closer to just 1 year.
Faster than Moore's Law, even.
In some ways, yeah. He tells this story. His MIT computer in the late 60s cost millions. Compare that to a, say, $2,000 PC in 2004.
The difference must be staggering.
Millions to one in terms of cost per calculation speed, per mixus. It really shows that curve shooting up. And even if Moore's Law for transistors hits a physical limit,
He thinks something else will keep the trend going, like 3D chips or something new.
Exactly. New paradigms will likely emerge to continue the exponential growth in computation.
So it's wider than just chips getting faster. He applies this accelerating returns idea elsewhere too.
Oh yeah, definitely. He looks at wireless communication capacity doubling every, 10 or 11 months?
Wow.
The internet, too. If you graph the number of computers connected linearly, it looks like nothing happened until the mid-90s, then whoosh!
Right, the explosion.
But plot it logarithmically. You see a clear exponential trend right back to the start, the ARPANET days.
So our perception is linear, but the reality is exponential.
That's a key point he makes. And then nanotechnology. The size of the components we build is shrinking exponentially, getting closer and closer to manipulating individual atoms.
Okay.
He sees genetics, nanotech, robotics, GNR. He calls it, they might seem separate, but they're all part of this bigger information revolution, all accelerating.
Okay, GNR. Got it. So this acceleration isn't just happening in isolation. Kurzweil fits it into a bigger picture, these 6 epochs.
Yeah, he has this grand framework, 6 epochs of evolution, starting with physics and chemistry, then life, brains, technology.
And the singularity is?
Epoch 5. That's the next big one. And the key thing about Epoch 5 is how transformative it is. It's where the lines blur.
Lines between what?
Between human and machine. Between physical reality and virtual reality. Stuff we currently see as totally distinct.
So it's not just better gadgets, it's a change in us, in what intelligence means.
That's the core of it. Moving beyond our biological limits. Our bodies are frail, they age, get sick. And our brains, our neurons, they're powerful, but actually really slow compared to electronics. Millions of times slower.
Right.
The singularity, he argues, is the potential to overcome that. Control aging, maybe even mortality, and massively boost our intelligence.
He talks about the knee of the curve, too, right?
Yeah.
The point where it goes almost vertical.
Yeah, where the exponential growth becomes super obvious, super fast. He thinks we're hitting that point, or getting very close, like right now.
So not centuries away, but soon.
His argument is that we're entering that period of rapid, noticeable acceleration. And before, say, 2050, the pace of change, which is becoming merged with us, will seem almost instantaneous from our current perspective, a fundamental shift.
Okay, this is a lot. Let's break down the specific technologies he sees driving this. The GNR revolution, genetics, nanotechnology, robotics.
Right. Let's start with G-genetics, the biotech revolution.
Okay.
Kurzweil sees DNA itself as, like, nature's amazing nanocomputer. Watson and Crick figuring out the double helix that was deciphering the code.
4-letter code, right? Storing information very efficiently.
Incredibly efficiently. Just 2 bits of information per base pair wrong. And it replicates with amazing accuracy. It has error correction. It's elegant.
So how does this drive the singularity? Is it about fixing genetic diseases?
That's part of it, but it goes way beyond. He calls DNA life's computer. Think about manipulating that computer.
Like reprogramming biology.
Kind of. A huge focus is reversing aging. He talks a lot about Aubrey de Grey's work.
Yeah. SENS, engineered negligible senescence.
Exactly. The idea isn't just slowing aging, but actually repairing the damage that causes it at the molecular level, making bodies functionally younger.
Is that feasible?
De Grey argues the basic science is mostly there. It's an engineering challenge now. Kurzweil points to goals like robustly rejuvenated mice in the near future.
Which would be a game changer for public perception, I guess.
Absolutely. People might stop seeing aging as inevitable.
And biotech does more than just anti-aging.
Right.
Drug discovery, gene therapy.
For sure. Drug discovery is moving from finding things by luck to designing molecules precisely, targeting specific disease pathways.
Makes sense.
And controlling gene expression, turning genes on or off using RNA or peptides. And RNA interference, RNAi. That's huge.
What does RNAi do again?
It lets you silence specific genes, like switch off a gene causing a disease or one a virus needs to replicate. Huge potential for cancer, viral infections.
Okay. He also mentions things like microarrays for testing drugs quickly.
Yeah, and classifying cancers more accurately. The tools are getting incredibly powerful.
What about designer babies? Does he get into that?
He touches on it, yeah. The idea of altering genes in embryos. But he actually thinks it'll be a slower revolution.
Slower. Why? Ethics.
Partly ethics, but also he believes it'll be kind of overtaken by the sheer speed of non-biological intelligence development. He sees it as reprogramming biology, which is inherently messy and slow compared to digital systems.
Interesting. Okay, so genetics is one pillar. What's the next one? Nanotechnology.
Right. And for nanotechnology. Manipulating matter down at the atomic and molecular scale.
So we're talking really, really small. Less than 100 nanometers.
Exactly.
Yeah.
And remember that exponential trend. The key feature size of our tech keeps shrinking. He predicted widespread nanotech impacting everything by the 2020s.
Which is now-ish.
Pretty much. And the potential is, well, enormous. Rebuilding the physical world, including our bodies and brains, molecule by molecule.
That sounds incredibly powerful. But surely there are big hurdles. It sounds complex.
Oh, definitely. Controlling assembly precisely at that scale, making sure nanomaterials are safe inside us, producing this stuff affordably, big challenges remain.
But we're seeing early examples already.
We are. Nanoparticles used as tags to find proteins or DNA, quantum dots, these tiny crystals that glow different colors.
For tracking things in the body.
Exactly. Tracking molecules, seeing processes unfold. Microfluidic chips doing thousands of tests on tiny samples. Scaffolds made at the nanoscale to help grow new tissues. And maybe the biggest area is medicine. Targeted drug delivery. Designing nanoparticles to go straight to diseased cells, maybe even cross the blood-brain barrier.
So delivering medicine right where it's needed.
Right. He mentions nanopills that might slip inside cells. Or implantable devices, like an artificial pancreas, releasing drugs precisely when needed based on sensors.
That's amazing. What about treating things like cancer directly?
There's research using things like gold nanoparticles. Guide them to a tumor, then heat them with a laser to destroy just the cancer cells, leaving healthy tissue alone.
Incredible precision. You mentioned quantum dots tracking multiple things.
Yeah, because they have unique color signatures, you can track lots of different molecules or cells at the same time. Gives a much richer picture of what's happening inside us.
Okay, so genetics, nanotechnology. The third one is our robotics.
Hmm.
But he means more than just physical robots, right?
Right. It's really the strong AI revolution, creating artificial intelligence that matches and then surpasses human intelligence.
How does he see that happening?
It's about understanding the brain, reverse engineering it, figuring out how intelligence works in information terms, and then implementing that on a much more powerful hardware.
Our exponentially growing computer power.
Exactly. He contrasts our biological brain, those slow neurons, limited connections, with what non-biological intelligence could be.
Faster, more memory.
Massively faster, vastly more memory, and crucially, the ability to share knowledge instantly. Imagine downloading skills or complex information directly.
Whoa. So it's not just about copying human brain into a computer.
Not necessarily copying its limitations. He suggests non-biological intelligence wouldn't be stuck in a skull, wouldn't have the same evolutionary trade-offs. You know how someone might be brilliant at math but terrible at music?
Sure.
AI might not have those constraints. It could potentially develop superhuman skills across many different domains simultaneously.
Okay, this paints a picture of, well, incredible potential, almost utopian in some ways.
Yeah.
But Kurzweil doesn't shy away from the dangers, does he?
No, not at all. He's very clear about the perils running alongside the promises. That old best of times, worst of times idea.
How so?
Our society is already so complex and interconnected, it makes us vulnerable to misuse of these powerful GNR technologies. Think about the internet, amazing tool, right?
Yeah?
But also enables all sorts of bad stuff. He worried about genetic engineering risks way back, and now he brings up nanotech dangers.
Like the gray goose scenario, runaway nanobots.
Exactly. Things like self-replicating nanobots getting out of control, consuming resources, gray plankton, gray dust. These are extreme, maybe hypothetical, but they highlight the risks of self-replication.
That's terrifying. So what's the answer? Just hope for the best.
Definitely not. He stresses we have to develop defensive technologies alongside the offensive ones, especially for biotech now and nanotech very soon.
Defense against misuse.
Yes. And he talks about regulation, government oversight, though he's a bit skeptical about whether you can really stop progress entirely.
Why skeptical?
He worries that trying to ban things outright could just drive them underground, making them harder to control. Might even backfire.
So it's more about guiding it safely.
That seems to be his view. Focus on strong ethical guidelines, transparency, building in controls. He mentions the Foresight Institute's nanotech guidelines, things like controlling replication, making sure nano devices are traceable.
So maximize the good, actively manage the bad.
That's the tightrope we have to walk, according to him.
Okay, now, obviously this whole singularity idea is pretty radical. It must get a lot of pushback, a lot of criticism.
Oh, absolutely. And he dedicates a big chunk of the book to tackling those criticisms head on.
Like what? What are the main objections?
Well, there's what he calls the criticism from incredulity, just people finding it hard to believe such massive change is really possible or possible so soon.
Just seems too sci-fi.
Pretty much. Then there's the criticism from theism. The idea that humans have something special, a soul or spirit that machines can't replicate, something beyond just material complexity.
How does he respond to that?
He talks about his idea of capability patternism. Basically, that even if consciousness and our abilities arise from complex patterns of matter and energy, that doesn't make them less real or less wonderful. The pattern itself is what matters.
Okay, what else?
There's the argument that computers are deterministic. They just follow instructions while brains seem more chaotic, probabilistic.
Right, they seem less predictable.
He counters that modern AI often uses randomness, and anyway, the universe at a quantum level is random. Plus, many AI systems are inspired by biology's messy, probabilistic nature.
And the regulation concern we touched on. The governments might step in and slow things down.
He acknowledges that. People get nervous about radical tech, but again, he's wary of bans, thinks focusing on defense and ethics is more practical. He also mentions things like the Turing test.
For telling if a machine is intelligent.
Yeah, and the Feigenbaum test. Benchmarks for AI capability.
What about the really deep philosophical objections? Like, Can a machine truly understand anything? Searle's Chinese room argument.
Ah, yes, the Chinese room. Famous thought experiment. Guy in a room doesn't know Chinese, but has rules to manipulate symbols so perfectly it looks like he understands Chinese from the outside.
Searle's point being the guy or the computer doesn't really understand. It's just symbol shuffling.
Right. Kurzweil pushes back hard on that. He argues a system advanced enough to pass a really robust Turing test would need genuine understanding, semantics, not just syntax.
It couldn't just be faking it.
Not convincingly over time, he suggests. He also kind of turns it around, saying maybe even our own neurons don't understand in Searle's sense. He thinks if you build a machine with the same causal powers as the brain relevant to thinking, it will understand. If you taught it Chinese that way, it would genuinely know Chinese.
That's a big claim. It really gets into the weeds of what understanding even means.
Exactly. And that leads straight into the deepest mystery of all. Consciousness.
Yeah.
Identity.
The hard problem.
Right. Kurzweil admits it's profound. Why am I experiencing this consciousness, this subjective feeling? He separates the objective side, the brain activity we can measure, the correlates of consciousness from that purely subjective first-person experience, the what it's like problem.
And how does he approach identity in this future of merging with machines? His patternism idea.
Yes, patternism. The idea that you are the pattern, the specific arrangement of information that persists over time, not the actual atoms, because those get replaced anyway.
Our cells are constantly being replaced naturally.
Right. So he uses thought experiments.
Yep.
What if you gradually replaced your neurons with functionally identical artificial ones? At what point, if any, do you stop being you?
His answer being,
That if the pattern persists, the identity persists. The stuff doesn't matter as much as the information pattern it embodies.
so it always comes back to information. Genetics is information. Nanotech manipulating information and matter. AI is information processing.
That's the unifying thread, our accelerating ability to understand, manipulate, and even become information.
And he sees this solving huge problems beyond just individual enhancement.
Definitely. Overcoming disease, aging, but also potentially tackling global challenges like resource scarcity, maybe environmental issues, by fundamentally redesigning our relationship with the physical world through nanotech.
So it's a future of continuous breakneck acceleration, almost inevitable in his view.
That's his core conviction. Based on extrapolating these exponential trends, a profoundly transformed future is not just possible, but near.
Okay, so let's try and wrap this up. Bringing this deep dive toward a close, Kurzweil's The Singularity Is Near basically paints this picture, maybe startling for some, of tech growth that's not just fast, but accelerating exponentially.
Right. Leading to a point, the singularity, where humans and tech merge. Driven by GNR genetics, nanotech, robotics.
With the potential to overcome our biological limits, aging, disease, even maybe intelligence caps, but not without huge risks and big ethical questions to figure out.
Absolutely. And while lots of people criticize the idea from different angles, feasibility, philosophy, ethics, Kurzweil tackles those objections, arguing the historical data and the power of information trends support his vision.
It definitely forces you to think, doesn't it, about what human even means, where we might be heading.
It really does. It pushes you to consider the trajectory, this potential future, shaped by changes unlike anything we've seen before.
And if you listening want to go deeper, Kurzweil points people to his website, kurzweilai.net. And there's a huge reading list in the book, too.
Plenty more to explore there.
So maybe the final thought to leave you with. If this kind of future unfolds, where tech reshapes almost everything about our existence, what parts of being human, what qualities or values do you think we'll hold on to the most? What becomes most precious?
That's a really good question to ponder as we navigate this accelerating world.